And now that I'm not muted, we can start. I think. Right, let's close this, open that. And switch that to live. Hi, I hope everyone's okay. Interesting, my chat overlay is not picking up messages, but the preview does, so whatever, that works. Does the YouTube overlay pick up restore chat? No, it doesn't either. Oh well. Now it does. Well, good thing YouTube's working as designed. Okay, so I'm got a very loose plan of thinking about how to visualize how maze is generated, because as we dive into more complicated algorithms, that might be valuable for debugging to just get a feel for it. And another thing is to just look at another algorithm. Beyond that, I'm not entirely certain. Oh, now the messages show up in my overlay. Okay. What is code forces? So, as a recap, last time we made random walk, which doesn't have a bias like binary tree or Sidewinder. And we have a few choices on how to represent how the code is generated, right? If we look at how the algorithms work, we tend to have always some sort of active cell we're looking at that we're manipulating. Sometimes on per row based, sometimes on just cell based alone, because binary doesn't care about the cell. And sometimes we have things like visited as in memorized cells that are currently being considered. Sidewinder has that as well with the run left and right here. I don't know if we want to visualize it. We could for now just visualize, and maybe that's what we're gonna do because that's the easiest thing. As the maze gets generated, we start with the full grid, and then just for every iteration, we're going to visualize basically the step here when that wall was removed, and do that until we're done. That's the easiest thing, because with anything more complex, we'd need to think more about the differences between algorithms, and maybe we want to have a few more before thinking about it. Or every algorithm will need to have their own visualization. So let's do that, I guess. So we probably want to just make a history then. That's the easiest thing, and then we can later augment it with other things. Let's go into types here and make a maze history. We'll need to clean up this file at some point of time, but that point in time is not now. Maze generation history. Oh, I just an array of mazes for now. I'm actually gonna save that for once. And every one of our functions here will need to have to return the history as well. So we have two options. We could put it as an argument here, as a parameter, and then it can fill it up and then returns only the maze. Or we could make it also return, instead of the maze, the history. Probably cleaner to just return it. We could also just return the history, because the last step in the history is the result, right? I'll just return both anyway. And we've got same thing here to do. And same thing here to do. And I'll learn the motions to do this more efficiently some other time. All right, and then we need to fix the errors. For now, we can just return the empty array. And these need to be fixed. Right. So everything should still work. Hopefully. We reloaded, it appears to still work, which is a good thing. And then thinking about it, the history itself is fine, actually. Let's add it anyway, like so. Because then we can work with more typing if we need to later. So we need to select which step to show somehow. So let's add buttons. Have a previous button, a next button. Let's do a show step. Here, and user state, which is a number. And we'll start with -1. So here we'll just advance the frame. From the previous, and if a previous was -1, we're going to roll over to 0. That is fine. But we do want to have a let's start on 0. And do a max here. Do I have the right number of brackets? I don't know. Okay. And for this one, we're going to do the same thing, just the other direction. And in case we should have asked for max, min up here, not max. And here we need to, sorry if I sound a bit dead, I'm feeling a bit sick. And this should be 0, right? We don't want to fall below 0 if we go back. Why are they flipped? Oh boy. And there we go. So we want max, we want to go to the right here, and that is No, wait. Yeah, exactly. We want to have previous here, that's the button on the left, and next on the right. And if we go to the right, we do not want to exceed the length, -1. And if we go to the right, we don't want, to the left, we don't want to go below 0. There we go. That shouldn't have been that hard. And then instead of drawing the maze here, we should pick from the history the one we actually want. I'm just going to do it here for now, overwriting the maze. With history, show step. If that is undefined, then we're going to instead show history Yeah, that's fine. History length -1. We're just gonna show the last one, and then a step before, if show step is larger than history length +1, so it's not in our array. That can happen if we, for example, switch the algorithm, because when our history is different, then we are going to do two things. We're going to let and set show step to history dot length -1. That should be a -1. We're also going to set this to dot length -1. And then we don't need this down here anymore, because we now know that our history is valid. Show step, like so. We'll probably have error. Void is not assignable to... Yes, because these need to be functions. Okay. We can do one more thing, because technically, if for some reason our history is empty, right? In this case, we're going to return we don't have a good option here because our select is down here. We shouldn't do this here. We should do it down here. History length larger 0. And then all of this goes here. that way, if we look at our what we're generating right now, because the history is empty, if we remember, we just returned the empty array, so we're not showing anything, but we still have access to the all the settings and the buttons, which we wouldn't have otherwise. This here doesn't quite work because the limit check is not in here, because we can set this to -1 if we wanted to. So we need to add the check here as well, which would be a candidate for refactoring to have this somewhere else and not both times in the same multiple times defined. As this is so short, this is still fine for me. And for now, let's also return the mason here to see that this works. So if we look at this, ignore that our buttons are on the right here. We seem to be able to render our stuff again. And let's put these buttons to a div. Which should fix that button layout here, which it does. And then now actually think about the history, right? So when do we push to the history? Or rather, for the history, we want to also be able to copy a maze, right? So let's find a function for this. This will not work though, because there's certain properties here. If we look at the definition of maze, rows and columns we can copy, but we cannot copy cells that easily. So cells we need to copy manually. We need brackets here because this is an inline function. Cannot find cells. Did you mean cells? Yeah. And maze.cells. Okay. So what we're doing is we're copying every row. And for every row, we copy every cell and we spread copy it. And our cells actually do not have oh no, it does. It has the walls object, so we need to copy the walls object as well. Yeah, copying in JavaScript, one of the worst things. I hate it. It's also super fragile because if we change the shape of our object, it'll easily break. But oh well. Anyway, we can copy a maze now. And now we just need to define when we are going to actually push to the history. For this, and for this we can do it after every step here, or technically we could do it before each, right here. So let's do that. Like so. I'm gonna copy that line and I'm gonna paste it here as well, because we never store the last change, right? Because once we're done with this loop, we're not going to hit this for now, so we wouldn't see the final state of it. And if we look at this, we should, for the Sidewinder, we don't. Okay. Why do we not? Do I have React tools? No, I don't. Okay. And let's do that the old way. So for some reason, we see the first one, which is good. So let's just console log out. I show step here. That doesn't switch. So 0 is okay. If we hit this, nothing happens. And if we hit previous, nothing happens. Which indicates that our... Why did I write on change here? That should be on click. I should stop opening random windows. Okay, now I count. Yeah. I have a super long delay between clicks and rendering. I don't know why. I shouldn't. But we can see the algorithm working. And if we wanted to be fancy, we could also animate it, right? So let's do that. So we're just adding a toggle here that when we hit this button, we're going to toggle if we're playing, and if play is selected, we're going to say if it's true, we're going to say stop, and else we're going to say animate. And then we're going to add a property here. And at this point, I'm starting to have quite a lot of properties here, and I might consider putting them into a more complex state and manipulating them with a reducer, but it's still kind of okay. What's the error here? Cannot find name P. Oh, right. Let's just play. But that's not the only thing we want to do, right? Because if we want to start playing here, another thing we want to do is, do we want to call a setter from a setter? I don't. We're going to do it like this. So we're going to set it to whatever play wasn't, and then we're going to set show step to 0. If play wasn't set. Like so. So if we start playing, we're setting it to 0. So when we hit animate, I don't really expect anything to happen, except that we re-rendered once with 0. So if I advance a couple times, yeah, if I animate, we're going back to 0, which is okay. And now we can animate this. Where do we gonna put it? Let's put it up here because it's an effect. Now we put this all into effect. It doesn't have the, it has a dependency on play. So if we're playing, we're going to do we set a timeout? What was it called? And there was another set interval, wasn't it? Yeah, set interval. Okay. And we are just gonna say a random number here. Which order round was it? It was first the handler, then the number. Okay. Then this way around. And we are going to set simply the show step to the next step. -1 or f +1. We're going to add the history here. And if history length -1 equals to the show step, then we're going to stop playing. Like so. History is used before declaration. And we're going to clear the interval in case anything changes here. Right. And this might animate. Not quite. I think we need a if play here. Like so. Because we don't want to animate. If we are not actually in fact animating. So if we hit my browser frozen? No button works. Oh, now it works. Okay. Well, we see it's animating. I don't know why my browser is really slow right now. I'm at 100% CPU usage. Okay, I'll look into that later. Anyway. What we can see though is the algorithm working. Quite slowly, but that's okay. And if we hit stop, it should actually stop. It does. Good. So that's that, and then we'll do that for the other meters as well, right? So we're going to do that and then return the history here instead. And I'm gonna do it the other way around because consistency is overrated. And then that's for that. That's already done. We're going to return the history here as well. And do the same thing here. After we carve the path. Okay. Every maze should have its history. We are already kind of into the, because we stopped the animation on like frame 90 or step 90, so we're already a bit into it. My browser froze when I hit random walk. The animation on random walk is probably more interesting than any other. Let me check my task explorer. What is taking everything? Firefox. Must be one of my other. Interesting. I have like 30 windows open. I'm assuming it's one of the windows taking a lot of power. This window. I can't select this one, right? You have also 10 gigabyte. What window is this? I apologize. End task. Anyway. There we go. This is not random walk. Is it? That looks like the sidewinder. It is. Anyway, we can switch it to random walk, or is this entering into a render loop? It's not. Maybe it doesn't like the history, because the history is actually fairly long. Especially on random walk. I suspect that's it. Yeah. Interesting that we're hitting gigabytes on this. It's not very memory efficient, even though we're mostly copying things. Because there's nothing we do here. This isn't efficient. Interesting. I guess a more efficient way would be to just copy the parts of the maze that changed per step. Well, one thing we can do, fix this. So just make this smaller. And that's one of the issues with functional programming that is levied against it often, is that it can take a lot of memory if you copy a lot of things. Ideally, you don't. And if you're using a language that has actually the features for it, you don't actually copy that much. Let's end this specific task again. And if we go for a random walk, we should have smaller one, and if we animate it, yeah. And what we can also see is that the random walk is actually really bad at picking a new path. We see it's going through a lot of frames while not making a lot of progress necessarily. And that's because it's just running around in the already explored one, and it gets worse and worse and worse as it meets the already, as there's less and less stuff it can hit. And I suspect we had probably hundreds of thousands of steps before, because you can see on 10 by 10 we're already hitting like 300 steps. And if we're thinking about it, 25 by 25, that's a number I cannot calculate, and which I should be. We have like what, 600 or something frames. That is if for every cell we actually succeed, but we won't. We will actually fail for, especially in the end, pretty much every attempt until we randomly walk into the right spot. And by 10 on 10, we should expect only 100 frames, and we're already at 500 frames. So yeah, also part of why I wanted to visualize the algorithms a bit is to see that it's actually struggling here. Right. Then let's think. We should. I don't like the position of that button. I just want to move it one up. That's it. And I think I may be calling it quits here. I apologize again for it again. I don't actually feel too good, and I'm running out of energy. Yay. Next time, we'll actually make another algorithm. And one thing that might be interesting, we took actually 1,000 steps to generate this. This is about 10 times more than we would necessarily need. Anyway, sorry for noping out fast. Goodbye.